Hello everybody and welcome back. So we are still looking at page 4 in the workbook here. And what we're about to do here is to give a general description of matrix multiplication. Okay, this is going to lead us to a definition. All right, so let's think of starting with kind of two arbitrary matrices A times B here. Well, not completely arbitrary. We need certain things to be true to be able to multiply them together. So we'll start with the matrix A that has m rows and n columns. We're going to multiply that by a matrix B that has n rows and p columns. Remember, again, we made the observation that for matrix multiplication to work, we need these two numbers to be the same. Okay, and then the product matrix over here, what would its size have to be? Okay, well, we talked about this in the previous video. The size of that product matrix would have to be m by p, kind of looking at the first and the last of those. Okay, and how do we describe matrix multiplication? Well, we're going to use the same kind of general principle that we did in the previous definitions that we already talked about. We're going to tell the reader of our definition how to come up with an arbitrary entry in the matrix AB, in the matrix AB. Okay, so think of just picking out an arbitrary entry in the ith row and the jth column. We'll call that the ijth entry. We'd like to describe how do we get that entry in our product matrix. Well, as we saw above, we take rows of A times columns of B, and in particular, we want to start with the ith row of A, which if we wrote it out formally would look like AI1, AI2, and so on until we get to the very last one in this row, AIN. And we're going to take the dot product of that row times the jth column of our matrix B. And if we wrote out the entries in that jth column, they'd look like B1j, B2j, okay, down to BNJ. Okay, and we took the dot product of those two entries, so that means then to get this arbitrary entry, okay, in AB, the entry that's in the ith row and the jth column, will start by taking AI1 times B1j then we'd move on and take AI2 times B2j okay, we just keep going until we get to the very last AIN times BNJ. Okay, and there's our description of how we find that entry over here in the ith row and the jth column of AB. Okay, so that leads us then, well, let's just first emphasize that this was the entry that we were looking for. Okay, so this leads us directly then to the definition 1.0.4. This is going to be our formal definition of matrix multiplication. Let's read this together and fill in the details. So if we start with an m by n matrix A, and we want to multiply it by an n by p matrix B, then AB is the m by p matrix, we made that observation above, defined by, and then ABIJ is going to be this sum that we have here. Okay, and we could write that out again, but it's convenient to write that in sigma notation. Okay, so that same sum that I just underlined in red can be rewritten like this. The sum as k goes from 1 to n of AIK times BKJ. That gives us exactly this expression that we wrote down above. Okay, and there is our definition of matrix multiplication.